All right, so
Why is it red?
we're going to find the area between two different shapes. So this one is a circle that is not centered at 0, 0, so you can see it. It's the darker line. I'm sorry they didn't print very well. And then the other one is a cardioid right there. So if you can see it, the cardioid is the really light one out here. And what we want to do is we want to find the intersection between the two to see where they cross each other, because we want to find the area between them. And so we want to know what little section am I looking for, an area that's part of the cardioid, where it would be easier to use the cardioid equation to help us find the area, and where would we want to use the circle equation to help us find the area. So we're going to set these equal to each other to find the intersection.
We might have a pencil, but I can't do this.
I got you.
No, I'm good.
And what do I do to solve it?
Try to get those.
I need the cosines to one side.
So divide by cos.
Not divide. Yeah, I could add these cosines to that side, or I could add these cosines to that side. We're trying to solve for theta.
Let's add 6 cosines.
Okay.
No, minus 2.
Minus the 2 over.
Divide by 4.
Okay. So where on the interval?
2 pi 3.
Yeah. Now this, real quick, this interval, right? This is a circle that's not centered at 0, so the interval to find this one is 0 to pi. But the interval for the other one is 0 to 2 pi. So that's kind of like that one wins, right? Just to be able to include both of the pictures, not just one of them. So we're looking at the interval from 0 to 2 pi. We want to know where the x-coordinate is -1/2, and it is. And then you can see what they did in the picture is they drew those in. Are you guys able to see that on your copies very well?
Yeah.
That they drew the 2 pi thirds in and the 4 pi thirds in. So we can see that this like ovally sort of shape, this egg kind of shape, is where the two pictures overlap. And we want to see which of the shapes we should use to find which part of the picture. So you can see they drew in this 2 pi thirds right here, and then they said that this part right here, they're going to use the cardioid equation to get it. You guys see, or the circle equation to get it. Does that make sense?
Yeah.
Because if you use the cardioid equation to get that little piece, you would get this part, but you'd also get all this stuff in here, and we don't want that stuff in there. Does that make sense?
Yeah.
So we have to use the circle equation because we just want this part, we don't want the stuff I just scribbled. So that means that from pi halves to 2 pi thirds, we're going to be using the circle equation. So I'm going to mark up here. So we're going to go from pi halves to 2 pi thirds. And I'm going to label, we're doing that because it gives us a sliver. Do you guys know what I mean by sliver?
Yeah.
That little sliver right there? Okay. And then if you can see this part right here, we don't want to use the circle for that, because if we use those angles from the circle, then we wouldn't just get this, we would get all this stuff out here too, and we don't want that stuff out there. Does that make sense? So we're using the cardioid to get that part. And so we're going to say that for the cardioid, we're going to go from 2 pi thirds, and I'm just going to go to pi, and I'm going to do that because that gives us half of our area, and then we can just go ahead and double it. Does that make sense? Now the other option is if you didn't want to have to double it at the end, you could find out what both of your slivers were. So one sliver is pi halves to 2 pi thirds. The other sliver would have been 4 pi thirds to 3 pi halves. And then you would have been adding together 3 different integrals. One integral for the first sliver, one integral from 2 pi thirds to 4 pi thirds for the big part, and then one integral for the other sliver. Does that make sense?
You would add all these together.
You would add all 3 of them together.
That gives you the whole circle.
And that would give you this whole area right in here, this like egg shape of where the 2 things cross each other. Now, I don't really want to do that because I'm like, why add 3 integrals together when you can only add 2 integrals together? So that's why I just went ahead and figured out what half of it would be, and now I'm saying just multiply it by 2. So now I can go ahead and use my area formula. So I'm going to say the area of the sliver . And that was from the circle, so we're going to put the circle in here. Plus the cardioid. And I'm going to take this whole thing, the answer that I get from this, I'm going to multiply it by 2.
Let's do it by hand.
What is it?
We could do it by hand.
Easy.
Yeah, let's not, because we do not have enough space for that. But go ahead and start typing that in. I need to grab my calculator.
You got it.
Got it.
Just go up, James.
Yeah.
So that would be the same as just not multiplying any of them by half. I just
Yeah. Yes. Yeah, that'd be the same as not doing that. Which I didn't think of, but I already typed it. So. Is that what we got? Wasn't that fun?
No.
Down.
So I think the hardest part of this is being able to figure out, especially when there's a little sliver like that, be able to figure out which shape you should use to find only the little sliver and nothing more. You have to be careful. So in this one we had to be careful. We couldn't use the cardioid because if we used that angle measurement from the cardioid, it gave us too much. So we had to make sure to use the circle. So you just have to think, like, if my goal is to find this inside region, which part of the graph do I use to find that? And we're not thinking in terms of something you can cut vertically or horizontally. We're thinking about stuff that we're rotating around a circle. So we have to be careful because it's like pie pieces that we're getting. All right. Example 2, find the common interior between this circle. So this is one where the interval is from 0 to pi. And then another cardioid, and that's going to be from 0 to 2 pi. And again, we want to be able to find what angle we have for where these two things cross each other. So I know that the area that we're looking for is right in here. Right? This like kind of egg shape again. That's what we're looking for. So I want to see what angle measurements I have that are going to cut it through here. So we're going to have that sliver thing happening again. Can you guys see it? We're going to have a sliver right there. Yeah, it looks like it. A sliver there. So we're going to go ahead and solve this, see where they cross each other. So 3 sine theta equals 1 plus sine theta. And what should we do to get the sine thetas to one side?
Subtract this.
Yeah, subtract this one over. So 2 sine theta equals 1. And that gives us sine theta equals 1/2. And yeah, which totally fits that picture, right? Yeah, there we are. So to get the shaded area, first I want to get this sliver. Should I use the circle or the cardioid to get the sliver? Circle. Can we all see how it's a circle? Okay. So I'm going to say the sliver is going to be the circle, and that's going to be from, what's the interval for that?
0 to pi 6.
0 to pi 6. Okay. And let's go ahead and find this one differently than we found the other one. So how do you guys want to go about finding this area?
Can we do it? You can do it there. Can we do it below the 3 interval?
Yeah, we can do it with 3. So we're going to say one sliver is from 0 to pi 6, and what's the other sliver?
5 pi 6.
To pi, right? And 5 pi 6 to pi. Okay, there's our 2 slivers.
Why did you say it was to pi?
Because it stops right here, and that's where pi is. So 5 pi 6 to pi would be this part right here. And then, I don't know what to call that. A good sized piece of pie?
Sure.
Hilarious.
How would you piece of pie that big?
Not small.
And that's coming from the cardioid. And what's the interval on that piece?
Pi 6 to 5 pi 6.
From pi to...
So we do from here to here,
I was-
and so pi 6 to 5 pi 6.
Are we doing that inside shaded part?
Mm-hmm. Yep. And that's part of the cardioid. So we're going to have 3 intervals this time. So 0 to pi 6 of the circle. And then we have that big region of the cardioid. And then we have the other little sliver. Nope, not 0. 5 pi 6 to pi. Yeah. So you don't have to do it this way every time, right? You can use your symmetry to your advantage if you don't want to have to type in as many things. Or if you want to break down each little area, then you can go ahead and do the whole thing like we did here. James, you letting me be your calculator today?
Yeah, so my fingers on my nose.
Did you say that's why your finger's in your nose?
One on my nose.
Oh, like nose goes. Oh, not too. Dolby. Mm-hmm.
What?
It's about thanks ESP.
I've never played the Giants in the playoffs.
Really?
Nah.
The act shows that.
They're commentators. Just a bunch of
Steve Adams.
Oh, dear.
Right, that was bad. That was bad.
Inside joke?
You guys, I'm over here working so hard typing these in. Mhm. How do my decimals support that I'm doing this right? Yeah, my slivers are the same as they should be. Yeah, and then my big area is bigger than the slivers, so that's good. All right, so now I got to do x plus y plus z. Anyone else do the same problem and get the answer, or are you just waiting for me?
Oh, no, yeah, we're just waiting for you.
You got the same answer? Marvelous. Alrighty. Weren't those fun?
I like these
Sure, is that it? A 3-part interval.
Oh no, we got more pages in this
Ew,
packet.
what is that?
Alright, go ahead and flip the page.
We got 20 more minutes.
Uh-oh. Alright. So now we're looking for this that is shaped like a lemon.
Oh,
Nice.
I love lemons.
That's a bird.
You don't love lemons.
Wow, that's not good.
Alright. Okay, so when the pictures look like this, it kind of messes with my brain about like which one's which.
Yeah.
So how do we know which one is the one with cos and which one is the one with sine?
Cos is sideways.
Cos has the axis of symmetry is like the x-axis or the polar axis. So is it the blue one or the black one?
The blue one.
The blue one. So this one is 5 minus 3 cos theta. That means this one is 5 minus 3 sine theta. Okay, so I'm going to do the same thing I've done before. I'm going to find the intersection between the two. And I can go ahead and subtract the 5. Yes. Subtract the 5 on each side.
Because it's going to be
You
cosine
can-
equals sine.
Yeah, and you can kind of tell from the picture usually. Yeah. Divide by -3 on each side. And we want to know the two places where the x coordinate and the y coordinate are exactly the same number, same sign. Mm-hmm. And 5 5/4. So pi fourths is right in here. And 5, and it actually just cuts it through right in half. Do you guys see that?
Well, I could.
Okay, does anyone have a strategy?
You have to try to do all the work.
Great
Oh,
strategy.
You.
We could find half of this and the other half. Since it's
Yeah,
going
so
down
we could just do 1/2 of it and double it. Okay.
So 1/2 would be the cosine, and the other half would be.
It'd be either
Yeah.
it'd be either cardioid.
Yeah, we could use either
Pi-
one,
yeah.
right?
Pi
But these aren't cardioids, right? What are these?
I don't
Lima.
know. Lima.
Limacons.
Lima beans.
Lima beans. They're lima beans. Do you guys want to find this half or find this half? The top half. Okay, we're going to find the top half.
Why do you go against me?
Sine.
We're going to find the top half. That's a sine. How did you know it was the sine one?
Because it's the black.
It's the black part. Okay. And then what's the angle on it?
It's going to be from
Pi fourths to
pi fourths to 5.
Pi fourths to 5 pi fourths. Okay, so we're going to do double because we're only taking half of the figure. And then the formula says 1/2 of our interval. We said our interval is from pi fourths to 5 pi fourths.
Mm-hmm.
And we're using this one, which is part of this limacon, lima bean thing.
Lima chong.
Would you accept lima bean?
Let me see on. Okay.
Did you hear that?
I just don't even know what happens
The sound
in
of
class. Yeah. I don't know if that's the sound of math.
That should be coming with class.
That's the sound of distress.
That's the sound of calculus.
What the hell is that? Did y'all hear that?
Chris?
But James, were you so
Martin, you got to open the door.
yeah.
You lost it.
Nah, I'll go.
Brandon, really?
be theta.
I'll go get it.
I got the answer. I got
He's
the
actually
answer.
doing what?
Brandon, ask
Oh.
for Brandon passport.
No one's at the door.
The knock on the door was the way that my mom knocked on my door as a child, and I immediately was like, "Get out!" No.
Was she like?
She wouldn't. She knocked on the door with her
That's what
fingernails.
it sounded like.
Yeah, that's what my mom always said. But you couldn't yell "Get out" because my mom's deaf, so she wouldn't hear it.
Mom's actually deaf.
Yeah, so you just like pound on the floor a lot angrily. Just kidding.
You know ASL?
I don't.
Oh.
I know like a few things.
So you have to talk like what?
I do. She reads lips. I talk very clearly. Hello, Mom.
Half my family.
All right,
That
arc
was
length.
very clear.
Arc length. All right.
Sorry, what the answer was 50.
If you guys remember from the previous units that we've done, that we've used two formulas for arc length. We've said one of them was 1 plus the derivative of the function squared. That was one arc length formula that we've used.
Are we using the Greek letter AB or you just write?
This is AB because this is in rectangular.
Okay.
And then when we did the parametric unit, does anyone remember what that was?
It's x squared plus y squared.
It was x
Squared.
prime squared, but you're
X
right.
prime squared,
Oh, yeah.
correct.
Same thing.
So for polar, it's going to be somewhat similar. We're going to say that we're going to take the interval this time from alpha to beta, since we're in polar and we do Greek letters. And we're going to have the square root of r squared plus r prime squared. Oh, this should have been dx. This should have been dt. So the formula that we use is they've all been kind of similar. Based off the distance formula, which makes sense because the arc length is the distance or the length of something. Alright. So let's do example 4. I bet you guys can talk me through it even though you've never seen one before. What's our interval?
0 to 2 pi.
0 to 2 pi. How did you know?
Because it's a cardioid.
It's a cardioid, yep.
Stop making noises, boy.
Alright, and then we've got square root of 1 plus cos squared plus negative sine squared. So our r prime was 0 plus, and then the derivative of 1 is 0, the derivative of cos is negative sine. So that was where Erica got that from. Okay. And we're ready to plug that in.
That's simple.
It's that
I
simple.
like this
Miss
problem.
Rose, do you think it's a coincidence that I have a deaf grandfather and he like knocks like that too?
No, dang.
I think what it is not really knowing what knocking is supposed to sound like, and just getting the idea of I'm hitting the door.
Well, he literally uses his fingertips and just like knocks on the door like that, like for like 5 seconds.
Because my guess is your grandpa can't whistle either.
He can't.
Yeah, my mom can't whistle.
I don't even know it's my grandpa. It's like a great uncle.
Well, it's funny because it's things that like there are things that you learn by being in social like contexts. You learn like the appropriate way to do whatever. And
Well, they were deaf since birth.
yeah.
They try to sound out worse. It just doesn't sound anything.
All right, we're good on that one. That one was pretty simple. Just use the formula. You're
I
okay.
like that one.
All right. Next one is surface area.
So we just got
We need to
one.
go back for this one.
So again, recall. So we're going to think back to our rectangular surface area. We had surface area is 2 pi, and it was the distance to whatever axis of rotation you had times the arc length. That was like the formula for it. So the distance to the axis was dependent about whether you were rotating it around the x-axis or whether you were rotating it around the y-axis. So if you were rotating it around the x-axis, then that meant you were rotating it this way, and the distance to the axis was the y, which remember we, instead of using an actual value of y, we just used the equation itself. You guys remember doing that?
Yeah.
And then if it was revolved around the y-axis, then that means it's revolved this way, and the distance between the curve and the axis was a length of x. And we just used the letter x. We don't have to, those were kind of easier. So that's what we've done in the past. So here, for polar, we're going to do the exact same thing. We're going to say that the surface area in polar is 2 pi. We're going to use our Greek letters, alpha to beta. And if we are going about the polar axis, sorry, I did not think ahead on this. We're going about the polar axis. Which axis is the polar axis?
X.
Yeah, it's the x-axis. It's the horizontal. If we are spinning around the polar axis, that means that we are spinning this way. Then the distance is going to be y, and y in this context is r sine theta. And then it's going to be that times the arc length. So that's times r squared plus r prime squared d theta.
Oh.
So do you guys see how it mirrors this formula? Or we have, if it spins around the axis theta equals pi halves, what's that similar to? The y-axis. So if it's spinning around the y-axis, then that distance would be x, which is r cos theta. Oh gosh. Oh, nope.
So how do you tell it's spinning around?
They'll tell you.
Saying
Yeah, so if you look at this picture, they don't always give you a picture like this, but when you look at this picture, you can tell they were spinning it this way, right, around pi halves. Okay, so let's go ahead and do our formula. We have r equals cos theta is the thing that's spinning, and so here they're telling us to spin it about pi halves, and this is a circle that is not centered at 0, so what is the interval for this? 0, you have two options, 0 to 2 pi or 0 to pi. It's 0 to pi, because remember the two is almost everything is 0 to 2 pi, and the two exceptions are roses with odd number of petals and circles like this that are not around 0. Circles that only show up on half the graph. Do you see how the whole circle is on half the graph? So we're going to say that the interval on this one is 0 to pi.
But say the center isn't 0, 0, but it crosses. It's like it covers. 0.
Yeah, if it's the circles where it's like r equals 2 and it goes around like that, then you would still do 0 to 2 pi.
Okay, but what if it's like almost
like off-centered but not
Yeah,
completely on one
off-centered,
side,
but
then it
not
should still be
off.
0 to 2 pi. Yeah. Okay.
So a regular circle from 0 to 2 pi?
Yeah.
It's not funny.
So we've got 2 pi in the front. Our interval is from 0 to pi. We are rotating about the y-axis, or about the line theta equals pi
So
halves.
that means it's the cosine.
Yeah, so we're going to do r times cos theta. So our r value is cos. So we have r times cos theta, which in this case gives us cos times cos theta.
So cosine.
Mhm. And then we have r squared plus r prime squared, and r prime is okay. So you can simplify that if you want, or you can just straight up plug that sucker in. 0 to pi cos theta, square root. Oh dang, I'll go back and fix it. Thanks for noticing that. $9.869 rounds up to 7. All right. How do we feel about that stuff?
Not
Pretty
bad.
good? Okay. Okay, what does number 1 say?
Well, she can't do it. This is gonna be
Okay, I'm going to graph the easy one. That's R equals 2.
Yeah, I already got it. It's not there.
Oh, that's good.
Back on mine
Yeah, I want to my circle.
Thank you. Okay, can somebody graph 4 sine 2 theta and tell me what it looks like? Or we already know what it looks like, right? We just want to know exactly where each thing is. So what is the graph of 4 sine 2 theta?
Rose.
The rows.
It has 4.
It's got 4 petals. Where are the petals located? You might have to graph it to see. You guys are just making me do the calculator stuff. All day today.
I'm kind of in front of you.
They're like, they fit at like 45 degree angles.
Yes.
Yeah.
Okay.
What?
Ooh, that was terrible.
The first one was struggle.
That doesn't look very nice.
Well, everything except quadrant 2 and quadrant 4.
Whoa, rude.
That's about
I
half.
don't appreciate
I mean, at least you're 50%.
Yeah, I can
At least 50%. At least you earned an F. Right?
It's a good curve on it.
When did you get an art class?
All right. That's all right. Okay, so the area between the two is what?
I don't even know.
Where do the two pictures overlap?
In the middle. The center. The circle.
I don't know what you mean.
So where do the circles and the rows overlap?
Pi 6, pi 3.
Everywhere they cross.
Everywhere they cross, but what's the area that we're looking for?
What are you asking?
So
in the circle.
the part of the petal that's in the circle.
Yeah.
Okay.
I don't know how to say that.
Yeah, I was
Inside of it.
confused.
You know what you meant by it.
We got 2 minutes.
If we don't finish it, I'll keep it going in the video, and then you guys can use the video to help you. Okay, so what's our first step? Like
Guys,
usual,
set them equal to each
set
other.
them equal to each other.
One half equals sine.
So theta is typically between 0 and 2 pi, so 2 theta is between 0 and 4 pi. Okay, so where on the unit circle is the y coordinate 1/2? 5 pi 6, and then if we go around the circle again, it'd be plus 12, 13 pi 6. And then this one plus 12, 17 pi 6.
That's God's way of saying stuff. 17.
Okay, I'll finish the video after school and then have you guys watch the end of it. I think the rest of the problems you'll be okay on, but this one messed me up, so I figured I'll mess you guys up too.
You were probably right.
Alright, so once you end up dividing by 2 to get theta alone, you get pi 12ths, 5 pi 12ths, 13 pi twelfths, 17 pi twelfths. So those are all of our intersections, it looks like. Well, maybe not even all of them. That's some of them at least. So we'll go ahead and draw, and if you guys can see, there's a little bit of symmetry here, right? Like we're going to see 4 of the same area. So I would say probably your easiest option would be to figure out, to kind of zoom in and figure out one of those, and then just multiply that result by 4. So pi twelfths is this intersection right here. And this is another one of those problems where we get a sliver. So if you think about which shape is going to give you the area of that sliver, you want to use the pedal to get the area of the sliver. If you do this degree measure right here and you do it from the circle, it's going to give you this whole thing, and we don't want that whole thing. We only want the sliver, and that comes from the pedal. So I'm going to say that my sliver is from the rows, and that's on the interval from 0 to pi twelfths. Now the next intersection was 5 pi twelfths, and that's going to be right here, right? 5 twelfths is almost at 1/2. And that's that other sliver right there. So what I'm going to say is, if I'm being lazy, those slivers should be the same because there's a lot of symmetry happening here. So I'm just going to say this sliver times 2. All right, and again, I'm not looking at the whole picture, I'm just looking at the part of the picture that's in that first quadrant right there. Okay. All right, now I have this like piece of pie here, and if you can see that, we do not want to use the pedal for that because the pedal goes all the way out here, and that's going to be a little bit of extra. So what we want to do is for this measurement from pi twelfths, so that's not pi over 2, that's pi twelfths, to 5 pi twelfths, from here to here, we just want to use the circle because we just want this inner part. So I'm going to say for the piece of pie, we're going to use the circle, and we're going to go from pi twelfths to 5 pi twelfths. And then we're going to take this whole thing, because that's just one of them, and we're going to multiply that by 4. All right. So I'm going to say 4 times. I've got my sliver. My sliver had 2 of those. 2 times 1/2. And that was from the rows. And then I have the part from my circle. Okay. And this makes sense because if you look at it, our slivers are very small and then the bigger area is bigger, so that's a good sign. So now I'm going to say that I need 4 of these, so I need 4 of what I stored as x plus what I stored as y. And the whole area is 9.827.